In this video, I'd like to talk about the math question of the day for Thursday, April 27th, 2023. And with this problem, we are given the equation of a circle, and we need to find its center and its radius. Now, questions like these, or topics like these, are usually taught either at the end of an Algebra 2 class or maybe in a pre-calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And with equations of circles, it's helpful to know the general form. We can write that a general circle somewhere located on the coordinate plane would have the equation x minus h squared plus y minus k squared, and all of this is equal to r squared, where the center of the circle is at the coordinate h comma k, and the radius of the circle, that is this letter r. And for the center, one way to keep this in mind is that the x value of our center is the value that makes this expression equal to 0. So in this case, it would be positive h. And likewise for y, the y value of the center of the circle is the y value that makes this expression with the variable y in it equal to 0. And again, in this case, it would just be k. So h comma k is the center of our circle. And once it's set up like this on the left-hand side, this is always equal to the radius of the circle squared. So we can notice from our equation that it doesn't look exactly like this. It looks like we have quadratic expressions in x and y, but we don't have any constant terms, and we have these linear terms for x and y. But what we can do is start by grouping the terms together. We can put the x terms and the y terms together. We can say that x squared minus 6x plus y squared plus 4y, all of this is equal to 0. And I left some spaces here because we can transform this to our general form by completing the square. We have these quadratics, but we can rewrite these quadratics in x and y as perfect squares by adding particular constants to each of those. And we'll add those constants to both sides, and from there we will get our radius. So when completing the square, let's make a little bit of room here, and we can work through that. We just need to remember the formula for a perfect square. Let's say we have x plus a squared, and if we multiply this out, we write x plus a multiplied by x plus a, and then use distribution to actually multiply this out. We would get x squared plus ax, or just 2ax, plus a squared. And let's focus on this quadratic and x first. Notice that we basically have the quadratic term and the linear term, but we don't have the constant term. We need to figure out what value we add here so that we can essentially go from this right-hand side back to our perfect square. And again, this process is just called completing the square. Now we can figure this value out, a squared, by looking at the coefficient on x, which notice in this case is negative 6. And we can just match them up. We can say that 2a, the coefficient on x in our formula, is equal to negative 6, meaning that if we divide each side by 2, a would be negative 3. And we need to know what a squared is. And if we multiply negative 3 by negative 3, we get positive 9. So in this case, with our quadratic with x, if we add 9 to both sides of our equation, this can now be transformed into a perfect square expression. And we'll come back to that later. Let's figure out what we need to add to y, or this quadratic in y, so that we can complete the square here. Now, even though the variable is y, we can still apply this formula, but just imagine all of the x's are replaced with y's, we can see that the coefficient on the linear term, which would be y if we switched everything, is 2a in our formula, and here is positive 4. So we can say that 2a is 4, or a is equal to 2, and we need to know what a squared is, and 2 times 2 is 4. So if we add 4 to both sides of our equation, we can now factor this into a perfect square expression. So let's do that for both our quadratics here. For the quadratic in x, notice that our formula is x plus a squared once we add that certain constant a squared, and we did that here. So this formula tells us we would have x plus a, and remember that a, when dealing with the x quadratic, was -3. So we have x minus 3 squared. And you can, of course, check this by rewriting it twice and then actually multiplying it out, and what you'll see is that it is equal to x squared minus 6x plus 9. So we have our perfect squared expression for x, and we'll do the same thing for y. We have y plus a now for our formula, and a in this case was 2. So we have y plus 2 squared, and again you can remultiply this out to check it, but it does work. And all of this would then be equal to 9 plus 4, which is 13. So we can compare this to the general form of our circle here, where the center, again, has an x value of h. It's the value that makes this expression 0, and a y value of k, which is the value that makes this expression 0. So we can apply that. We can see that positive 3, would make this equal to 0. So let's write this down. We have that our center has an x value of positive 3. That makes this expression 0. And a y value of -2, since that makes this expression 0. And then the equation is equal to the radius squared. So we now know that our radius, or our radius squared, is equal to 13. So if we take a square root of each side, we can find that our radius is the square root of 13. And we do need to be a little bit careful. When we take a square root, we would usually put plus or minus, but the radius is always the positive distance from the center of the circle. So in this case, it would be positive, the square root of 13. And of course, if we do want to check this, we can take our original equation, plug it into some type of graphing calculator like Desmos, and see for ourselves that it would have a center at 3 minus 2 and a radius of the square root of 13.